Today we will discuss how to determine the refractive index of transparent material using polarization of light by reflection. तर मी तुमच्यासाठी स्क्रीन शेअर करतोय. Myself, Dr. Dhananjay Gujarathi. In this presentation, we cover the following topics. We want to determine the refractive index of the transparent material. Now, topics which are to be the cover in this experiment. First, we will discuss about the theory behind to determine the refractive index of a transparent material. That is what is meant by light, then the polarization, then the Brewster's law, and by using this Brewster's law, that means the polarization by reflection, one can determine the refractive index of the transparent material. The aim of the experiment, then what are the apparatus which are to be used to perform this experiment, then the ray diagram, then how to perform this experiment, the observation table, calculation, and the result. Now see here, as such theory it is to be the concern, we will study the behavior of the light first. You are familiar with that. The light, it is to be the dual in a nature, that is a particle in nature as well as wave in nature. The rectilinear propagation of light, the reflection of light, the refraction of light, these properties of light can be explained when the light, by considering the light as a particle in nature, and the interference of light, diffraction of light, as well as the polarization of light can be explained with the help of the wave theory of light, which are to be explained initially by that of the Huygens scientist. Now, as such, wave nature of the light, it is to be the concern. We know that the wave, there are two types of the waves. One is a longitudinal type of the wave, that is called as the mechanical waves, and the transverse type of the wave. The polarization of the light, with the help of the polarization of the light, one can easily explain that the light, it is to be the transverse in nature, not the mechanical in nature. Now Maxwell studied the wave nature of the light. That means the light, it is to be made up by that of the electromagnetic wave. What exactly the electromagnetic waves? Now see here, if the light, it is to be the travels along that of the x-axis, that means the light, it is to be the propagated along that of the x-axis, then the electrical field as well as these are the magnetic field. This is the magnetic field and this is to be the electrical field. That means electrical field vector and magnetic field vector both are to be the perpendicular to the each other and perpendicular to the propagation of light. This is the nature of that of the electromagnetic waves. Now, electrical field of vibration, that means electrical vectors of the light, are responsible for the vision, and hence we forget about the magnetic field vectors and consider only the electrical field vector, that is the electrical field of vibrations. In this diagram, this is to be the vibration of electrical field. This is to be the vibration of electrical field vectors, which are to be the perpendicular. That means it is in the direction of y, perpendicular to the propagation of light, and propagation of light it is to be the considered along that of the x-axis. And this is the pure transverse in nature, and every vibration will have a particular plane of vibration. That means the vibration of that of the electrical field vector, it is along the YZ plane, and the propagation of that of the light, it is along the x-axis. Now the common source of lights are incandescent lamp, candle flame, fluorescent lamp. All these sources of lights emits the electrical field vibration in a number of directions. This type of a light beam, which has a vibration in more than one plane, it is called as unpolarized light, and it is to be represented like this. That means vibration of that of the electrical field in all possible direction along that of the YZ plane, and the propagation of that of the light along that of the x-axis. Now this light, this line represent the vibration in the direction of plane of paper. That means this is the paper. Then vibration of this electrical field in the direction of plane of papers, and this dot indicates the vibration in the direction perpendicular to the plane of paper, like this. That means unpolarized light can be explained, or it can be defined, it can be shown with the help of the line with the arrow. This is all about, in short, that means light, it is dual in nature. The Maxwell electromagnetic waves, electrical vectors and magnetic vectors, they are perpendicular to each other and perpendicular to the propagation of light. Then the electrical field, considering only the electrical field vibration, because it is responsible for the vision, and this is the transverse in the nature of that of the light, and these are the unpolarized light. Then what exactly the unpolarized light? A beam of light which has the vibration of electrical field vectors in more than one plane is called as unpolarized light. Now this is the unpolarized light. It is to be represented with the help of the line with a dot. The line with a dot. This is called as unpolarized light. Then what is the polarized light? Now such a unpolarized light, if it is to be the pass through that of the calcite crystal, this is the calcite crystal, it is also called as a polarizer. It has the one axis. It has the one axis, and that axis is called as a crystallographic axis. Now, when unpolarized light, such an unpolarized light, if it is to be the passing through that of the polarizer, Then what happens? The vibration of electrical vector which are to be the parallel to the crystallographic axis, they pass through that of this polarizer, and others vibration like this. This is a perpendicular vibration, dot it is represent the perpendicular vibration of electric field. They are not passing through that of the crystallographic axis, but they are filtered or they are stopped or they are absorbed by that of the polarizer, and only the electrical field, the vibration of electrical field which are to be the parallel to that of the crystallographic axis, they are passing through that of the polarizer. And such a type of the light, it is called as a polarized light. Now see here, there is no dot. There is no dot and there is no dot. And only the line it is to be there. That means the vibration of electrical vector along only one line, that is a parallel to that of the crystallographic axis, which is a perpendicular to the propagation of light. That means a beam of light which has only one plane of vibration of electrical field vector is called as polarized light. Now see here, this is the A, B, C, D. This is a plane, and this plane, along this plane, the vibration of that of the electrical vector is represented, and hence this plane is called as the plane of vibration. While perpendicular to the plane of vibration, there is another plane, that is E, F, G, H. Actually, there is no any light it is to be the vibrate, that means vibration of that of the electrical vector along this plane, it is zero. That means there is no electrical field vector along this plane, and hence such a plane is called as the plane of polarizer. Now we want to explain the polarization of a light. That means how one can find out the polarization of light by using that of the reflection, and this theory it is to be explained by that of the Molus. Now see here, in this diagram, this is a transparent medium and this is the air medium, and consider this is to be the normal, and this is nothing but the incident ray of light. Now see here, this incident ray of light is the unpolarized light, and it is to be the incident on that of this transparent medium, just like as a glass. Then obviously the incident light, it is to be the reflected as well as it is to be the refracted. Okay, that means this is the incident light, this is the reflected light, and this is the refracted light. Now when unpolarized light, if it is to be the fall on that of the transparent light, then the reflected light, now see here, this is a reflected light, it is a partially reflected, a partially polarized. This is a completely polarized, this is to be the unpolarized, this is unpolarized, this is also a partially polarized. That means at a angle, at a particular angle here, if the incident light it is to be the unpolarized, then reflected light it is to be the partially polarized, and the refracted light it is unpolarized. Now see here, if we increase the angle of incident, then at a particular angle of incident, this unpolarized light it is to be the completely polarized in the reflection. In the reflection. And such an angle of incident is called as a polarizing angle. And this is nothing but the polarization by reflection. Then Brewster explain like this: when the light it is to be the incident at a polarizing angle theta p, at a particular angle of incident theta p, at the surface of a transparent medium, this is a transparent medium, then the refractive index of the medium, that means refractive index of this transparent medium with respect to the air, index of the medium with respect to the surrounding medium, that means air, is equal to the tangent of polarizing angle, and hence the refractive index is equal to mu is equal to tan of theta p. What is the mu? Mu is the refractive index of this transparent medium, and theta p is the polarizing angle. Now, this is about the short representation of this reflection, polarization by the reflection. Now, experimentally, how one can find out the refractive index of this transparent material? That means the aim of this our experiment is to find out the polarizing angle by using reflection of light, that is the theta p, to verify the Brewster's law, that means mu is equal to tan of theta p, and by using the Brewster's law to determine the refractive index of a given transparent material. Now see here, this is the ray diagram. Now, this is the prism table. On this prism table, the ABC is the prism, where AC be the base, AB be the reflecting surface of the prism. Now, this is the collimator, that means light it is to be the fall on that of the prism, it is to be the reflected, here it is to be the polarized or polarizer, and this is the telescope. That means through this telescope one can see the how to unpolarize light, it is to be the polarized by that of the reflection. Now, what are the apparatus which are to be the used to perform this experiment? You are familiar with that of the monochromatic source of light, that means sodium as a monochromatic source of light. This is the light, monochromatic source of light. This is our spectrometer. In this spectrometer, this is the collimator. This portion is a slit, that means light it is to be the passing through that of the collimator. This is the telescope. This is our prism table. And with the help of these screw, one can level this prism table. There are two windows, this window 1 and this is window 2, like this. Now, first we want to find out, that means to perform any experiment we are using the any instrument, then first we must consider or we must find out the least count of that instrument. Then how to find out the least count of the instrument? Now see here, this is the position of the window. Now this is the vernier scale and this is nothing but the main scale. Okay. Now, to complete this circle, there is a 360-degree. Now, consider the value of the smallest division on that of the main scale. How to find out this? Assume that it is a 190 and here it is a 200. Then in between the 190 and 200, there are 10 degrees and there are 20 divisions. That means the value of the smallest one division is a 0.5 degree, that is a 30 minutes, and total number of divisions on a vernier scale is a 30. That means a 30 minutes divided by 30 is equal to 1 minute. Now see here, the least count is nothing but, that means representation of least count, that is a physical interpretation of least count, is nothing but how much smallest value can be measured with the help of that instrument. Here our instrument is a spectrometer. The value of the smallest division on the main scale divided by total number of division on a vernier scale. Therefore, the least count is a 0.5 degree, that means 30 minutes divided by 30 is equal to 1 minute. Now here, the least count of our spectrometer is 1 minute. Then how to write down the total reading? Now see here, the total reading is equal to main scale reading plus vernier scale reading multiplied by least count. Now see here, main scale, if you consider the main scale reading as a 122 degree 30 minutes plus vernier scale, that means a line of vernier which is to be the coincide on that of the main scale, that is a 16 multiplied by its least count as a 1 minute. Therefore, total reading is equal to 122 degree and 46 minutes. This is nothing but the how to write down the total reading when we are performing the experiment. Now, determination of refractive index by transparent material by using this spectrometer. Initially, before starting to perform this experiment, the spectrometer should be in, that means whatever may be the parallax which are to be the present within this instrument, it should be minimized or it should be eliminated. And hence we use a sisters method. The one part of that of the sisters method is the leveling of that of the prism. Now, initially, after the sisters method, we must write down a direct reading. Then how to find out the direct reading measurement? Now see here, this is a monochromatic source of light. It is passing through that of the slit of the collimator, and it is directly seen through that of the telescope. And whatever may be the reading which is to be obtained in a window 1 and window 2, it is called as a direct reading. That means this is the view of a direct reading, the view of that of the slit like this. Then write down the direct reading here like this. This is window 1. This is a telescope reading for direct measurement. Here is the main scale reading, line of coincide of a vernier scale on main scale, that is the vernier scale reading, and multiply by its least count, then per it is a total reading is here. For window 2 is also the main scale reading, then vernier scale reading, and then total reading like this. Now, how to measure the angle of polarization? This is the view to place the prism on that of the prism table at the position of angle of polarization. Now see here. This is our collimator. The light it is to be the fall on that of this prism, and it is to be the reflected back, and it is seen through that of the telescope. And this is the polarizer which are to be rotated like this in a clockwise direction or in an anti-clockwise direction. We are considering initially in that of the clockwise direction like this. Then at a particular angle of incident, whatever may be the light which is to be the reflected, and it is to be the seen through that of the telescope, its intensity of the reflection should be 0, and that position is called as the angle of polarization. Now see here. Initially, the slit it is for a small angle of that of the incident. The intensity of that of the slit, which is to be the seen through that of the telescope, it is like this. By changing the angle of incident, its intensity it is to be the reduced. Again, by the changing of that of the angle of incident, the intensity which is to be the observed, it is to be the 0. And then this is the position of angle of polarization like this, where whatever may be the intensity which is to be the observed through that of the telescope, it is to be the 0. And then write down this reading for that of the angle of polarization. And this is our observation table for the polarization. This is window 1, main scale reading, vernier scale reading, total reading. For the window 2, main scale reading, vernier scale reading, and total reading. Then how to find out the polarizing angle, that is the theta p. We are measuring here the angle is a theta at the position of polarization, not the polarizing angle directly. The difference between this A and minus B, A and B, it is here for the window 1, it is here for the window 2, and its mean, that is the theta, it is to be the here. That means we are find out the angle theta at the position of polarization. Now see here, I will explain how this polarizing angle theta p is equal to 90 minus the theta mean upon the 2. Now see here, with the help of this diagram, now see here, this is a collimator, this is the incident ray, this is a reflected ray, this is a normal. Now the position A is for direct reading. Now here it is to be the telescope for that of the direct reading, and that direct reading it is to be the considered as R1, and this is the position of the polarizing angle, position of a telescope for the polarizing angle. And we want to find out the angle of an incident I is equal to theta p by using the Brewster's law. Theta p is equal to the angle of incident where we get unpolarized light, it is to be the converted into the polarized light. Now see here, this is the angle 1 that is considered. Now at polarization, that means at this position. Angle I is equal to angle of theta p, angle I is equal to angle of theta p, that is the angle of polarization. Now from figure, angle DEC, D, E and C is equal to angle BEC is equal to angle I, and angle AEB is equal to theta. Now this theta it is to be the measure. That means direct reading, and this polarizing position reading, this is nothing but our theta, which is to be the measure with the help of our experiment. And these three angles, if it is to be added, it is equal to 180 degree. That means angle 1, angle 2 and angle 3. It is a 180 degree. Now angle 2 is equal to angle 3 and angle 1 is equal to theta. Therefore this I plus theta is equal to 180 degree. 2I plus theta is equal to 180 degree. And angle I is equal to theta p. Therefore 2 times theta p plus the theta is equal to 180 degree. Therefore theta p is the angle of polarization is equal to 180 minus theta upon 2. That means 90 minus theta by 2. Where theta p is the angle of polarization, theta with the angle measured by the spectrometer at a polarizing angle, which is equal to the position R2 minus R1 or R1 minus R2. Now, after this, filling this observation table, by finding the angle theta, one can calculate the polarizing angle as a theta p is equal to 90 minus theta mean upon 2, and the refractive index is equal to mu is equal to tan of theta p. That is the tan of angle of polarization. In this way, one can determine the refractive index of the transparent material by using the polarization by a reflection. Thank you.